Okay, and good morning to everyone. And that was Thelonious Monk. And Ernie, I have no idea what cut we were listening to. Blue Monk with Thelonious Monk. In the last hour, what I've done is some updating. So just so you're aware of that, I went ahead and I entered the problems from 6.5, 6.6, 7.1, and 7.2. So those are the actual problems on the website. And as some of you are aware, I did extend some of the computerized homework so that you could do that through the week. Catch up. You're welcome. Now, I have some questions. Sandra, yours was the first one, I think, and then I will go to Shamra's. So go to Shamra's first. Okay, Shamra, do you want to?
Yeah, it's out of 6.5.
Okay, out of 6.5, is it a particular problem number?
Yeah, it's number 25.
25 in 6.5. And if I understand what Shamra was sharing with me earlier, this is a problem in which decimals were intended. You changed it to fractions, had no problems with fractions, but when you went ahead and tried to do it with the decimals, then you hit trouble. Is that correct? Okay, so number 25. Ernie, as we take a moment here, I'll go to the book on this. Now 25 is just one you tried. It wasn't one that was assigned,
Right.
but we'll try it. So this is the problem. Let me write that on the board so that we have something we can reference. And it is number 25. This is 6.5 as a section. And we have 2/5. We're dividing by a negative 0.8 and plus 1/3 squared. Now first, taking it from the standpoint of what you did. The 0.8 is 4/5, right? So you said, in essence, you had 2/5 divided by 4/5 plus 1/3 squared. Is that what you did when you converted it to a fraction?
No, I put the 8 over 10.
Okay. Reduce 8 over 10 for me. Thank you. Okay, so you could have done 8 over 10. That is 4/5, okay? But I concur. That's the wisest thing to do because I now divide first. And this turns out very nicely because I can go ahead and reduce here and reduce here. And this became just 1/2. So I'm adding that to 1/9. And I think it lends itself very nicely to the solution because my LCD, and I need to get that plus sign so it's centered a little bit better, but the LCD is 18 because they're relatively prime. So I'll multiply here by 9, and I'll multiply here by 2. And so the intermediate step, 9 plus 2, which is prime, 11 over the 18, and it works very nicely. Now, as a decimal, this suggests that we're going to have a not-so-nice problem because I'm going to have 1/2 of 11/9. So I'm going to have a repeating decimal, it looks like, coming out of this, and I'm not real pleased with it, but let's try it. Decimal version. 2/5, also known as 0.4. Okay, good. So we have 0.4 divided by a negative 0.8 plus, did you put 0.33333333, etc. squared? Well, no. Well, if you do this, and you understand the 3's go forever, you'll be okay. But 1/3 squared is 1/9, and 1/9 is 1's forever. So this is just going to come out a bunch of 1's forever. This part, I need to do the division, so I'm going to rewrite that as 0.4 over 0.8. That's a division. And this becomes 1/2. So I have 0.5 plus 1's forever Hence 0.6111111 forever.
But when I checked it in the book, it was .038. Yeah, negative .038.
Okay, just a minute. I made an error. I was adding, and I neglected to see what? The minus sign. That was my DAE in both cases. Because I totally, let's come over here too, Ernie. I just neglected that, and I am remiss in doing that because this was a negative here.
Right.
So when I said I had a 9 plus 2, I should have had a 2 minus 9, and so that should have been what? Negative 7, and I just glossed over that minus sign. Okay, so we both glossed over the minus sign. Yes, I have the same reaction, but I can't say it. Here, this is a negative, so that's a negative, and so that's going to change my answer. Now, the problem is there's no way I can go ahead and subtract ones from forever from that in a reasonable way. So this, if I think of it to like the thousandths position, so I might think of having a 0.5, and let's just throw in maybe that many, go to the 10 thousandths, that I'm going to have a 1, 1, 1. And so as I do that, and because thinking of borrowing for the moment, although I typically don't like to do that, this would become the 4, and of course these becomes the 9s, and the last one ultimately becomes a 10. Now the problem is these ones never end, so I technically have 0.4999999. We haven't talked about that particularly, but I'll take an aside just for a moment. We know that 1/3 is 3s forever. I know 2/3 is 6s forever. And so the nice ploy on this is to add the left and the right side, and you get 1 is 0.9 forever. And one of the things you learn about a calculator, that if you see a 0.5, it does have an infinite decimal expansion. It is 0.499999 forever. So if I know that, and I come back up to here, that these are going to be 9s forever going across here, and I have 1s forever across here, then I know this is going to be a 3, 8, 8, 8 forever. That is, I believe, the correct answer with a negative sign. Now, what do they give in the back of the book? Okay, negative 0.388. Let's see what they have. Negative point, and they just, do they put a line over the 8s? Okay, technically, if you were going to truncate, they do have a line over the 8s. Okay, because if I just did this, this is sometimes referred to as truncating the remaining digits rather than rounding off. So if it is truncated this, if you were to round off, and again there would have to be some agreement to where you want to round off, you might say, okay, I'll carry it that far to the nearest thousand. But this is the most accurate answer. But I don't think this is very obvious to most students that 0.5 can be written as a 4 with the 9s going forever. And that comes out of this problem. You remember the old schizophrenic rabbit problem? We never did it? We didn't let you do that, huh? Yeah. Well, no, this is a schizophrenic rabbit where he goes back and forth between... Okay. Talk. We now will talk. I have a rectangular parallelepiped. Okay, I have a hole in this and a hole here. And there is a rabbit sitting there in the box. The rabbit is curious. So the rabbit sticks its head out of this opening. Looks around, bored, decides, okay, I will switch sides. Takes 1/2 a minute to switch sides. And look out the other opening. Never satisfied, the rabbit decides to do it again, but this time cuts the time in half at 1/4 of a minute. And continues in his boredom. And so the question, if that's how long it takes as you keep track of the moves, how long before the rabbit has his or her head out of both holes at the same time? That's the question. And it's known as the schizophrenic rabbit. Okay, split personality. Okay. How do you do it? You change them to decimals. So let's change to a few decimals. 0.5, then 0.25, 0.125, 0.0625. Those are pretty easy ones to do. We've done those before. And so what we do is we keep track of the subtotals after 2 moves, 3 moves, 4 moves, 5 moves, and you were to set a table. So the first move, you did it in 0.5 seconds. Minutes, I'm sorry. The next one went to what? 0.75. Right? 0.5 and 2.5. Then add in 125 and you get 875. And then you add in 0625 and what do you get? No. 0625 added on to this. It goes to 0.9375. Correct? I'm just adding. This is not doing anything particularly aggressive. What's the next one going to be after the 0625? 03125? So if I add 03125, this next one goes to what? 0.96875. And you just keep adding these in. What do you think this number will eventually become? No, it's not. Well, small is relative. Okay? What is it approaching? True, a never-ending number. What never-ending number? There are an infinite number of moves because this rabbit just goes forever. We're still not getting it. I have 9, 6, 8, 7, 5. What's my next move going to take? 0, 1, 5, 6, 2, 5? Well, I'm trying to divide those in my head. Well, I'm doing it's 1/2 each time, correct? So 2 goes in there 1. That left 1 left over. 2 goes into 10, 11, 5, leaving 1 left over. So that's in there. Just a moment. Let's make sure I did that. I think I just made an error in my head. I'm dividing by 2 for each move because I cut the time in half. So this is 0.01 with 1 left over. That's a 5 with the 1 left over. And my error, I had 625. No, I had it right. Okay. So I add that on to here. And I have what? A 0.015,625. And what is that becoming? Well, I have a 5, a 7, a 3, a 14, an 8, and a 9. Is it approaching something? Well, next move, I divide this by 2 for the time for the next move. Thank you. The decimal we are approaching is going to be this decimal. You get closer and closer to that decimal. What's that a decimal for? 1. So how long before the rabbit will have its head out of both holes at the same time? 1 minute. An infinite number of moves within 1 minute and will have its head out of both holes at the same time. Okay. Sandra? Yes? Well, in 1 minute, an infinite number of moves. And what's the time between this side and that side. It goes to 0. So when it goes to 0, pretty soon all you see is the rabbit's head out of both holes at the same time. The time between moves, each move. 0.5 the first move, 0.25, 0.5 minutes, half a minute, then a quarter of a minute, then an eighth of a minute, a 16th, a 32nd, a 64th. I'm just adding those fractions together as decimals, which is what Shammer was wanting me to do. And now you know about the schizophrenic rabbit. And there's a nice punchline to this. What is another name for a rabbit? Bunny rabbit. A hare. So if you complain about this, then you're really splitting hairs. Going on. Shammer, does that answer your question? Now you've heard about the schizophrenic rabbit. By the way, there's a neat picture of the schizophrenic rabbit in the supplementary units that was in the first version of the book we wrote for Math 10. So much for that. Okay, there's a whole unit on schizophrenic rabbit. You could complete that now, and you can see how it's set up there. Any other questions from 6.5? Yes? You have a problem. A problem from the book or from the computer? The computer. Am I going to have to go to the other side? Maybe. Okay, Ernie, let's go to the other side. Is it a problem like anything in 6? It's like that one, almost. Okay, well, let's go back to the document cam for just a moment. So we have something very similar to what we just did before we started chasing rabbits. Okay, so James is going to share a problem with me. Look at the problem above that one. Okay, so the 23, which is minus 2 and 4 ninths, times 1.8 and minus 3/8. It's like that one? Okay, I'm still going to, I think, go over here. I'll just write the 23rd problem down. So this is number 23. So that'll make it nice. We have a negative 2 and 4 ninths. Now, after what we said in that last problem, what would be the decimal for this? For negative 2 and 4 ninths? No, the decimal, not the improper fraction, the decimal for it. Okay, I'm wanting a pattern that I'm clearly not getting. We said 1/3 was 3's forever, correct? Just a minute. 1/3 is 3's forever? But 1/3 is 3 ninths. Note. 2/3 is what? Close. 2/3 is 0.6666 forever, correct? But that's really 6 ninths. Do you see the pattern? 9 ninths was 9's forever. So what do you think 4 ninths is going to be? Slide over just for me, Ernie, if you would, please. 4 ninths. Not 2's forever. 6 ninths gave you 6's forever. 3 ninths gave you 3's forever. 9 ninths gave you 9's forever. Yes. 4's forever. So this is negative 2.44444 forever. I like that 4's forever. And I don't think we want to set this up this way because of those 4's forever. But that's how you do it if you were going to go to decimals. So I think I would go with the improper fraction that I think Kim was going to give me, in which we had the 18 and 4 is negative 22, and I'll try to remember the negative sign this time. And that is multiplied by 1 8/10, which is 18 over 10, which I will leave as 18 over 10. Okay, 1 8/10 is 1. Otherwise, your 1 8/10 can be written this way. We usually say 1.8, but 1 8/10 is that way, and then you multiply, getting 18 over 10, which you could write as 9/5. Yes or no? I have 1.8, correct? 1.8 is, read this out loud for me. 1 and 8 tenths. 1 and 8 tenths. 10 times 1 plus 8, 18 over 10. One digit after the decimal point. The tenths place. We got it? Now, do you have some warm, fuzzy feelings right here? You should. The 9 and the 18 just made you nearly euphoric, right? Now what? No. Either cancel here or here. If you want, do this. How about negative 22 over 5? Now, there's no way I'm going to trade this in for that mess. Even though I'm supposed to be working with decimals, it's not good. I don't know how you're going to handle those 4s forever by that 1.8 and make sense out of it. So that's one of the difficulties, I think, again, just choosing numbers to throw in here, because this now is a negative 3/8. And again, the nice thing about this, these are what? Relatively prime. So your LCD is their product. So I have a 5 here, a 5 in the top. Here I'm going to have an 8 and an 8. That's a pretty sad-looking 8. But at any rate, that's 176 and a negative 15, a negative 176 and a negative 15. So that's negative 191. So I have a negative, let's see, I better not do that. This becomes negative 191 over 40. And I just leave it that way. I had a 10 here and a 22 here. They were both even. Okay. Maybe that's where 2 came from. Dos. Okay. We got it? I could have also done what here? I could have just divided the 2 into here and the 2 into there and had 22 over 5 that way. So there are a couple of ways of doing it. Now, I have no idea what the computer would show for this, James, as far as trying to do that infinite decimal and run a 1.8, because it's just not going to lend itself to something very clever. And let's see what we can do, just for the heck of it. And I don't know what's going to come out of this. We're going to have these 4s, right? I'm just going to put dot, dot, dot. And let's see what we get as we multiply by 1/8. Now, I know I'm going to have a 2 at the end, technically speaking, because 8 times 4 is your 32. But I'm going to do what? Carry the 3 at that point. So I'm going to get a bunch of 5s. And then, finally, when I get to that last one, this becomes a 19. Now, when I multiply 1 times that, that's pretty straightforward. That's just going to be a 2, 4, 4, 4, 4, 4, 4, etc. This technically will just become a bunch of 5s. That's the only way I know creatively of doing it. And when I do that, I know I'm going to get a bunch of 9s. Then I'm going to get a 13, a 6, and a 2. That does not look well to me, and I've done something rather badly, because I know that that should be 3 something. What have I not done there? 8, 16, 19. With no carry, that's my problem. I would not have been over there. I would have been here. And so this would have then been the 4 at that point. I'm trying to anticipate where I would have had my digits. See, with the 8, I had a carry. With this one, I didn't, to get that next digit. So this would have been 43999. I know a decimal is going to have to go there. So my guess is, in the back of the book, they would write a negative, a negative, probably 4.39s forever. Well, I just had to say roughly 2 times 2 is 4. That's my guess. Now, I don't know how close I am to that looking at my correct answer, which here is 40 into this. But if I take 40 into 191, I know that is going to go 4 times. And then I'm going to have a 3, 1, and a 0. And that, okay, I still have something messed up because what? At this point, this appears to be an 8. And that's where I'm missing something, and I don't see it. I had 2, 4, 4, 4, 1, 8. That would have been a 32, carry a 3. That's going to be a 19. I have no problem with that. And then this would have been, there's my problem. Dadgummit curl. That was a 2. That makes that a 4, 3, 9, 9, 9, which is what I had here. But if I do that, I'm not getting that value here, which appears to be at about a 7. And I'm not seeing where that would come out of here as I multiply, and that's what's bothering me. I can get it down here, because this is going to be 280. Then I'm going to get a 30, and as I bring down another 0, that's going to go another 7, 280, giving me a 20, and then a 5. Now, how I'm going to get that out of a negative 2.44444 times a 1.8, and I'm trying to see where I would have lost it up here. I had 8 times 4 is going to give me the 32. That carries a 3 all the way through. So that's going to give me 5s until I get what? 35 here, carry 3. That's going to give me the 19. Now, the 1 is certainly going to be the 4, 4, 4, 4, 4, and 2, and so on. And at the moment, there's my error. I have that part. I'm not bothered by that. I do have that correct. What am I supposed to subtract now? The 3/8, which is 0.375. Okay, now we've subtracted 375 from this number. And, well, they're both negative, so let's see what we get adding that together. So I'm going to have a 4.3, what appears to be 9s forever, which is known as what? Okay, it's working. It's very obtuse. I have this, and then I'm adding to it a 0.375. Now, before I do that, a comment for you. This is an infinite decimal expansion for what? If I just keep getting these 9s forever? No. That is negative 4.4. Okay? And so if I had negative 4.4, and I then take a negative 375, I'm going to have my negative 4.775 I'm getting. Now, if I leave these 9s in, remember these 9s just keep trucking. I'll have 9s, 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 and then I have what? A 4, and then that becomes a 7. Okay, just a moment. What am I doing? I had a 4, 3, 9, 9, 9, and a 3, 7, 5. This is becoming that's becoming the 7. That becomes the 7. This becomes the 4. We're there. And this is negative 4.774, 9s forever, which is the infinite decimal expansion for negative 4.775. Good grief. Okay, I don't like that. You have to understand that those 9s forever after a digit is an infinite decimal expansion for that. That is a bear of a problem. And I got so focused up here on doing this product that I forgot to subtract off the 375 and was wondering why I wasn't getting the right answer. And I could have spent the next hour on that and never had it right. Now, question. Which is a better way of doing this problem? I think, without a doubt, over here. And this isn't pleasant, but it beats the devil out of working with these infinite decimal expansions, which I don't think the text really expected you to do. And by the way, a calculator doesn't help a whole lot on these. Yeah, because you end up, the calculators are only set up, sliding over now a little bit more. When you do something like what I've done here, they usually just truncate and they drop off. Otherwise, the calculator, the program written, which is like a small computer, it'll only carry so many digits. So they just drop off the other digits and say, okay, they're gone. Well, a calculation you do, you will never get to exactly this number. What you more likely will get is a 4.39998 or something like that, because they drop off the other digits, and there's nothing to tell you that those nines are going forever. Unless your calculator has a few enough digits in it that all you see are the nines. Then you've got a suspicion that's what they mean. So, as a problem, let's go back to my original premise. On these problems, when you set up a database to change problems for you so you can do 15 different problems, all the same, you just pick different numbers to put in, it's dangerous. Particularly when you want your reader to do it with decimals. This one is not one that you would do with decimals, and I think you would probably just give up and say, I'll ask in class. And we have gained nothing out of this that helps us pre-algebra, other than I have been able to show you the schizophrenic rabbit. I owed you that one for a semester. And I've also been able to share with you how any, and I mean any terminating decimal, can be written as a repeating decimal. And that's worth knowing. And we are dangerously close to a discussion about calculus. The problem in the schizophrenic rabbit is essentially a calculus problem, because we talk about a limit. Okay? You've heard that problem in another way, and this has to do with the tortoise and the hare out of early Greek mathematics. It became an Aesop's fable. What is the story about the tortoise and the hare? Okay, they go to a race, right? And the hare is a bit of a braggart, overconfident, arrogant, an arrogant rabbit. And decides, hey, I'm so far ahead I can go into the bush and get 40 winks, wakes up and sees the tortoise about to cross the finish line. And then what is the problem set up as? And of course, Aesop's fable is the tortoise goes over, and if you're slow and steady but keep at it, you'll win. But the Greek version of that, the rabbit cuts the distance in half each time, and then cuts the distance in half again. And so the question is, do you ever pass the tortoise if you keep cutting the distance in half? Well, from a logic point of view, you never do. But in reality, the rabbit gets ahead of the tortoise and crosses the finish line. And that is a paradox. And it was known as Zeno's paradox. There's another version of that that says if you have an arrow going through the air, I can tell you the position at every single point in time. How does it then continuously go and come down if it can be stopped at every point and you see its location? The idea of something being broken into a very small piece being something continuous. In physics, you hear it as particle theory versus wave theory. When you look at light, we talked about the speed of light. So these all morph together. I mean, my point is, you talk about a problem like this in arithmetic, and you can immediately go into physics. You can immediately go into calculus, and you can go everything from the early Greek mathematics of Zeno's paradox all the way up through Newton's calculus and talk formally about a limit. It's not all separated into just pre-algebra and algebra and so on. The minute you start talking about it, you're talking about mathematics in a very general way. Hence, this problem to me was worth discussing because it brought up some things I would not normally talk about. Yes? Okay, this part up here, I said it was multiplying by 8, and I have to understand these 4s go forever, correct? So when I take that first 8, this 8 times wherever that 4 is, I get a 32. But then I carry a 3, correct? So 8 times 4 will be 32 plus 3 will be 35. So except for this last one out here, which was a 2, everything else is a 35. But see, the problem was there was no last 4. So I'm never going to have that last 5 becoming a 2. So you have to understand the dot, 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 which is meaning the 5s went forever. And that's
actually simpler, I think.
well, it's simpler in some ways, but then that requires from you a conceptual understanding that these 5s make sense, that they go forever. Now, somebody who doesn't conceptually get that and says, hey, wait a minute, you had a 2 at the end. Where did you throw that? Well, because I had 5s. I have 4s forever, therefore 5s. But you don't have a last 4. You know, it's just, you get into an argument, and you get nowhere. Still, with all that said, the fractions worked very nicely. Agreed? Okay. Thank you for the question, James. Thank you for the question, Shamra. Sandra, do you still have your question? Okay.
It's problem 41 in the book.
All right, I get to go back to the book. You're sick?
No,
Oh, 6-6. Okay, I'm sorry, I didn't catch that. Okay, so from 6-6, we finally get out of 6-5. Okay, just a moment. There we go. Document cam was messed up. 6-6. And the problem number, I'm trying to get to the set of problems there. Did you say 41? Stay awake, Natalie. I heard that yawn. Oh, okay, here's my diagram. A 14.5 beam attached to a vertical beam, 3.5 above the horizontal support beam. You're now contractors. Okay? And we want to know how long this horizontal support must be. So what famous theorem? I feel like we're doing the millionaire thing in Slumdog. Okay, what famous theorem do you use? Pythagoras. The Pythagorean theorem, or just say Pythagoras for the moment. I started to change that midstream. And I have a problem with the right triangle. And I have a suspicion that the problem is not with anything regarding the theorem, which you understand reasonably well. This is 3.5, and this was 14.5 here?
Yes, 14.5.
Okay, I sort of like those from the standpoint that they end in 5, and I can use a shortcut. Don't know it's going to help me any. But we know from the Pythagorean theorem that x squared plus 3.5 squared must equal what? 14.5 squared, agreed? Because this is a right triangle, and the square of each side added together must be the square of the diagonal. Did we get it set up correctly? A squared plus b squared equals c squared. Okay, the numbers are going to be a little bit nasty here, but 3.5 squared is 12.25. Why? My shortcut? I've done this so many times. You go up a number. So 3 to 4, 3 times 4 is 12.25. So I have x squared plus 12.25. You can play the same game here. Go up 1, that's 15. 14 times 15 is 225 minus 15, which is 210. If I did that right? Again, 14 times 15. I know 15 squared is 225. 14 times 15 is 225 minus a 15. So that's 210, so I have 210.25 without the calculator. Do we agree in the numbers so far? So then I'm going to subtract 12.25 from both sides because I want to eliminate the term on the left. I eliminate terms by subtraction. I remember eliminate factors by division. Factors are multiplied, terms are added. That's got to keep coming through your head. Get rid of a factor, you divide or multiply. To get rid of a term, you either add or subtract. Okay? Now, Subtract from both sides. I love it. The two 5s are gone. Yes. And I have 12 from that, which is going to come out 198. Now, do I know something about, I mean, I'm supposed to estimate this, right? What's 14 squared? It's one of them I want in your head. 14 squared. It ends in a 6. Can't be 296 because 15 squared was 225. 196, right? So I'm darn close to 196. So I know x is going to be 14 something. Okay, so now I can guess at what, a 1 or a 2? Okay, we guess at a 1. So 14.1 times 14.1, and we see what we get. That's 141. That's going to be a 416.5, and that's going to be a 141. And so that's going to be a 187.891. And so I'm over by what? 81 hundredths. So it's got to be less than 14.1. So maybe 14.08. And then I try that until I zero in on it or get bored or go to a calculator. So approximately 14, rounding off. So to the nearest digit, unit, 14. Does that answer your question, Shamra? Not Shamra, Sandra asked that one. Got the yes right. You guess. What is the answer given? I'm curious. You're going to check. Like at Christmas time, checking it twice to see who's naughty and nice. Waiting. Okay, we are waiting impatiently. Do we have an answer yet? 14.1 to the nearest tenth. Well, if it's 09 or 08, then we'd round off to 14.1, and we did that without a calculator. Now, did they ask you the answer to the nearest tenth? They just assume that when you look up the answer, it'll be to the nearest tenth. That bothers me. It should have been to the nearest tenth. Then I've been happy. Okay, I have spent the usual more time than we should by your measure of covering the questions on the previous material with the hope of covering the new questions, and nobody asked anything about all those neat diagrams, finding volumes of shapes. We're okay with that? Nope. Yes, they are time consuming. Okay, so I think we can go math light this morning with what I'm going to do next. Now, Sarah and I had a discussion about this. This is a content in 7.1. And she decided not to go this route. I think I'd like to, particularly after what we've just done. Rolling the dice. We're into 7.1 now, part of 7.1. Rolling dice, probability. Now, just because it's interesting and because it deals with fractions and decimals, you're looking like, where is 7.1? Have we managed to get to 7.1 yet? Okay, what page are you on, Tabitha? 502? Will you turn to 502, please? All of you. Are you on 502? No, you weren't. Where were you with the dice on it? 504. Okay, 504. I'm assuming you've all played either Monopoly, Monopoly, or something with dice. Now, I keep hearing something played with dice. Called craps game. You use with 2 dice, but you can play Yahtzee, and it has 5 dice, and Yahtzee's a lot better. You don't lose money in Yahtzee. You just get excited. But a die is the singular for dice. So pair of dice, or a die. And a die is, in essence, a cube with 6 sides. A parallelepiped of particular form. And it has little dots on it, which you count. And these are the possible numbers you can roll if you roll a die. We call this a set. It's a collection of the outcomes. So I put little parentheses around it and call it a set. And I'm going to call that S, typically, for the outcomes I can get. S for space. We call this the outcome space. Now what's neat about these outcomes is that every one of these numbers has the same chance of occurring. So if I let X, this time, represent the outcome, then the possible values of X are 1 through 6. And I could ask you a question like this. What percent of the time, if you just kept rolling this die forever, and you just counted how many 3s you got, what percent of the time would you get a 3? Now, instead of saying percent, we're going to say probability. And so the probability that an X equals a 3 turns out to be 1 out of 6, which, by the way, is a decimal you don't like, because it's 0.166666 forever. But as a fraction, it's very nice. And what I want you to realize is that each of these have the same chance of occurring, and one of them was considered a success. So in a very simplistic way, the probability of that success is how many ways it can happen out of the total number of ways that you could get an outcome. So this turns out to be 1 out of 6. And for any one of these numbers, you get 1/6. So then we ask questions like this. If you wanted an even number, what's the probability that X will be even? Well, I'm going to then count how many of these are even. 1, 2, 3 evens out of the 6 possible, and we would round that off, or reduce it to 1/2. 3 out of 6, right? Now, if you roll 2 dice, the problem gets to be much more complicated. And what page are you on, Shamra? To the right side. Is that 505? I couldn't remember where the other one was, so that was a clever way of asking. Page 505 at the top, you find what happens if you roll 2 dice. Do you not? The 2 dice are up there? Or is that cards and dice? Yeah, forget that then. If you were to do 2 dice, you would get a diagram with a lot of dice on it. So I'm going to leave that for a moment, and I'm going to resort to what you've always been wanting to know about, the stat course. Because this is a topic we have in statistics, and it's at the early part of the course, not all that early. The idea of probability, and what I'm going to do is show you the diagram for that problem. Here, and they do it, and by the way, if you go to a gambling place, not that I recommend it, but if you were to go to a gambling place and lose your money, and you will, that's the way it's set up, you would have the dice the same. There'd be 2 red ones or 2 green ones, but here we're going to do a green and a red for Christmas. So let's go to the document cam. There are your outcomes, and there are 36 possible outcomes. Okay? So you can get a 1, 1, a 1, 2, 1, 3, 1, 4, etc. Then you come down to your second row, and you can get a 2, 1, a 2, 2, 2, 3, 2, 4, etc. Finally down to 6, 1, 6, 2, 6, 3, until you get to what? 6, 6. So there are 36 outcomes. And this becomes a very important problem for us, because if you can do one thing 6 ways and another way 6 ways, 6 times 6 is the way you can do it together. So we'd have 36 separate outcomes. The Yahtzee problem, 5 dice. So you take 6 times 6 times 6 times 6 times 6. And it turns out to be 7,776. So you'd have to have a table with 7,776 different possible outcomes. Now, a Yahtzee is what? Getting all 1s or all 2s or all 3s or all 4s or all 5s or all 6s. There are only this many ways in the spirit of my grandson. Okay, 6 ways out of 7,776. That's the probability of a Yahtzee. So probability is just a lot of counting and being very clever about it. Now, with the craps game, it gets a little bit more dicey. Good pun. Because when you roll the 2 dice, okay, then you don't win or lose in certain throws. So if I happen to throw a 4 the first time, then I get to keep throwing until I either get another 4 or get a 7, at which point you just said you lose. You go, oh, craps, or crapped out. And so with that involved, you can ask, what's the probability of winning? You can either get a win on the first roll, or you can get wins on subsequent rolls, and it's a much more complicated problem. So rather fascinating subject area for probability. So with that covered, now back to chapter 7. That was my intro. And we have probability determining probabilities. And so here is the definition in 504. Theoretical. The theoretical probability of equally likely outcomes is the ratio of the favorable to the total possible. And that's just exactly what we talked about. And so they give the idea of a coin landing heads. Okay, so that's 1 out of 2. The heads will be favorable. There are 2 possibilities, so 1/2. That's beginning probability. And it gets a little more complicated as you change the way the game is played. So the probability of rolling a 2 on a 6-sided die, I did a 3, but here's the same argument in your book, and it comes out 1/6. Interesting little comment here. What's the probability with a 1-sided die that you'll get one of these numbers, a 1 through 6? Well, it's going to be 1. You're going to get one of them, guaranteed. In the same way, if I take that 2-headed coin that you're not supposed to flip, what's the probability of getting tails on a 2-headed coin? 0. So the impossible event is called 0. The guaranteed event would be called a 1. And I think there are a couple of common sense notions here that I just want you to be aware of, that just because the probability is small doesn't mean it won't happen. If you really believe that, you wouldn't play the lottery. Okay, so if the probability is very small, it just means it's not going to happen very often, but it can still happen. Okay, so we understand that. You say the probability that you're going to survive surgery is 0.95. Go ahead. Probability you're going to survive surgery is 0.15. Not now. Probability is too low. So we understand that. If they say the probability of rain today is 80%, you take an umbrella. If they say the probability of rain today is 10%, I might get my bike ride in and stay dry. We live our world in probability in many respects. So that's what this is an intro for. It's a very light intro. I have a full unit in those supplementary units of probability because we ask, and I'm just going to finish off with this. We talk about events. So when I said I had an even number throwing a die, that was an event, getting it even. And it is a set containing 2, 4, and 6. The event of getting an odd would be the set containing 1, 3, and 5. So I can have different events. We usually label them A and B. Big A, big B. Now, I can ask you the 2 following questions, and then we spend about a day or 2 on this kind of problem in the stat course. What's the probability of the 2 events happening at the same time? Well, in that case, 0. But let's say I get heads on the first coin, and I toss it again and get heads again. So what's the probability they get a head in the first toss and a head in the second toss? And we say that you multiply the 2 probabilities 1/4. What's the probability they get a head in the first toss or a head or a tail on the second toss? That kind of thing. A or B versus A and B. And my point is, when you ask for the probability of one thing or another happening, we add the probabilities, typically. When we say the probability of one thing and another happening, it is multiplied. So if somebody says, I want the probability of this and this happening, it's going to be less than either one by itself because we're multiplying fractions. So 1/2 for getting heads, 1/2 for getting heads again. But getting them at the same time, 1/4, smaller number. So the problems that are involved here, and this whole unit is about ratios, the idea of ratios. And there's some very nice problems in here about unit pricing that you're all familiar with in the market. What's the price per ounce? It's like dimensional analysis. And it's of some use. In our society, it's usually done for you. There's only one more part that I'd like to look at in terms of ratios that did get brought up. Somebody asked about trigonometry, did you not? Didn't we get asked about that with angles and trig and what it means? Well, here's the argument of ratios that I talked about on page 502. And we just have a statement as we come to the document cam. The ratios of the vertical or the horizontal. We talk about the incline, and we said that was the tangent. I'm going to come back to that tomorrow. So all I want you to do is try to get caught up. I'd like you in 7-1 to do a little bit with the probability, have some questions in that. I'll finish up that section tomorrow. We ran out of time today to do any more than that. So with that, Ernie, we go.